Hello, AP Calculus. We are going to continue our work on topic 6.7 and 6.8, and we are starting at the bottom of page 33 here with using the fundamental theorem of calculus. So recall from topic 6.4 a very important theorem that illustrates the importance of antidifferentiation. So this is what we call the fundamental theorem of calculus. This is basically our definite integral theorem. It tells us that when we have integration from a value a to a value b, that when we integrate it, we get the antiderivative, and we take plug the b value in and subtract the a value plugged in. So we're just going to jump right in and start trying some of these. So example 7 says evaluate each of the following definite integrals. So we know when we integrate 10, we would get 10x, and that goes from -2 to 4. And then I'm going to plug in those values. So I do 10 times 4 minus 10 times -2. 10 times 4 is 40. -10 times -2 is +20, so we would get 60. Let's look at this one here. I would probably rewrite it. So I'd rewrite it as x to the 1/2 power dx. When I integrate x squared, I would get x cubed over 3 plus, when I add 1 to this one, I would get x to the 3/2 divided by 3/2 or multiplied by 2/3, not plus c because we're definite. We're going from 0 to 1. So I'm going to plug the 1 in. When I plug 1 into this first one, I get 1 cubed is 1, so I get 1/3. When I plug 1 into that one, I get 1 to the 3/2 power, which is still 1. So I have 2/3, and then I subtract, and I write a parentheses. I'm going to put 0 into this first one would give me 0. 0 into the second one would give me 0, so the back piece is just 0. So I have 1/3 plus 2/3 is 3/3, which is, in fact, 1. That says thirds. Okay, let's take a look at C. So C, I would probably take, well, I don't really need to. I could take that 2 out front. I don't have to. It's just going to hang out as a coefficient. And we know from the last lesson that our trig integrals, when we integrate secant squared, we get tangent of theta. And we're going to evaluate that from -pi/4 to pi/4. So I'm going to do 2 tangent of pi/4 minus 2 tangent of -pi/4. So remember your pi/4s are here and here. This would be your -pi/4. And we know that they're square roots of 2/2. In this one, it would be square root of 2/2 comma negative square root of 2/2 because we know sine is negative in that quadrant. So the tangent of pi/4 would be square root of 2/2 divided by square root of 2/2, so it's just 1. And then the tangent of -pi/4 would be negative square root of 2/2 divided by square root of 2/2, so it would be -1. So we would end up with 2 times 1 is 2, -2 times -1 is +2, so overall we would get 4. All right, much like what we saw in the last lesson, we're going to rearrange this before we actually take the integral. So we're going to go from 4 to 9 I'm going to split it into 2 separate integrals, and I'm going to switch to the 1/2 power. So t to the 1/2 power minus t to the 1/2 power divided by t to the 1/2 power dt. So I know that this is just 1, and then this I need to bring upstairs with a negative exponent. So t to the -1/2 from 4 to 9. And then we're going to go ahead and add 1. So add 2/2. So we've got t to the 1/2 minus t from 4 to 9. And then I'm going to go ahead and plug in. I am going to go ahead and switch that back to the square root. So square root of t minus t from 4 to 9. So we have the square root of 9 minus 9. minus parentheses the square root of 4 minus 4. So square root of 9 is 3 minus 9 minus parentheses 2 minus 4. So 3 minus 3 is going to be 0. I don't think I did something wrong. Square root of 9 times I forgot to multiply by 2, guys. So when I integrate this, I forgot to divide by the new exponent, which was 1/2, which would make a 2 out in front. So this is going to be 2 times 3. And then the same thing here, it should be 2 times square root of 4, or 2 times 2. So I have 6 minus 3 minus 4 minus 4. So that's going to zero out, and we've got 6 minus 3 is going to be, what happened? Should have been a negative 9. I made my 9 a 3. So this should be, I don't know how it became a 3. It's a 9. So 6 minus 9, which is negative 3. I think we finally got it. All right, let's take a look at e. So when we know when we integrate e to the x, we get e to the x. We're going to go from 0 to the natural log of 5. So I'm going to put these in. So we get e to the natural log of 5 minus e to the 0. Well, with log properties, we know e and natural log cancel, so we've got 5. And then e to the 0 power is just 1, and 5 minus 1 would be 4. I'm going to choose to rewrite this to make it look a little bit more like something we know. So I'm going to bring the 3 out in front. So we've got 3, the integral from 1 to e squared of 1 over x dx. Now we're going to integrate. We know that 1 over x is the natural log of the absolute value of x, and we're going to go from 1 to e squared. So we've got 3 natural log absolute value of e squared minus 3 natural log absolute value of 1. I wrote way too big. We know that we could just drop our absolute values because everything's going to be positive. So 3 natural log of e squared minus 3 natural log of 1. I know that I could do a couple things. I could take this 2 and bring it in front and multiply it with a 3, or I know the e and the natural log cancel, and then we are multiplying the 2 and the 3. So either way. Natural log of 1 is 0. So I have 2 times 3 is 6, 3 times 0 is 0, so my final answer is 6.